Introduction to atoms and elements. So elements are substances that cannot be broken down further into different substances or different items. Elements consist of atoms. And atoms are the building blocks of all matter. So elements consist of only one type of atom. Elements are displayed on the periodic table of elements, and there's a link to the periodic table here. As I mentioned, atoms are the building blocks of all matter. When you get many atoms together into a substance, that substance is known as an element. Atoms are composed of three main parts: protons, neutrons, and electrons. Protons have a positive charge, and they're found in the center of the atom. The center of the atom, also referred to as the nucleus of the atom, is where you would have both protons and neutrons. So neutrons have a neutral charge. They are not charged. Circling around the protons and neutrons is an electron cloud. Very much like our solar system has planets that circulate around the sun. The electrons circulate around in an electron cloud. And electrons have a negative charge. So with the positively charged nucleus or center of the atom and the negatively charged, or it attracts those negatively charged electrons that are floating around the outside of the atom, because opposite charges are attracted to each other. So we're going to draw a couple examples. I'm going to go to the periodic table here, and let's actually go forward with the definitions, and then we'll draw some examples. So an atom versus an element versus a molecule. So atom, those are the individual units. So those are the building blocks of all matter. When you put multiple atoms together, you can form an element. So that's multiple. An element consists of many of the same type of atom. A molecule is when you put two different elements together, or even two of the same element together, and bond them together through different types of bonding mechanisms. So a molecule would be more than one element bonded together. The atomic number is the number that orders the elements on the periodic table. The atomic number is the number of protons that's in the nucleus of the atom. The atomic number being the number of protons in the nucleus. In an uncharged atom, we also have the same number of electrons as protons. So our atomic number gives us our number of protons in the nucleus, and then if it's uncharged, it also gives us the number of electrons. The mass number is the number of protons plus neutrons. So mass number, we just add up the number of protons and the neutrons in the nucleus, and that's the mass number. Atomic mass does account for the actual mass of the electrons as well, but the mass of the electrons is so tiny that usually the mass number and atomic mass are extremely close. A sample mass number calculation will be performed once I start drawing out the number of protons, neutrons, and electrons that you would find. So here you can see the shorthand expression for the different, or for a sample element. So you can see nitrogen here. Nitrogen has the symbol N, and here you can see it's charged, so this one has a charge. The mass number is given on the top, and the atomic number is given on the bottom. The mass number will always be greater than the atomic number. Why is that? Because the atomic number is just the number of protons. The mass number is the number of protons plus the number of neutrons. So the mass number will always be larger. So looking at this, we're going to go through some examples of how to calculate the number of protons, neutrons, and electrons, and then we're actually going to draw out these atoms. So here we can see Na. Now there's a link to the periodic table right here. I highly recommend that you print out a copy of the periodic table and have it next to you during this lecture, because we're going to come back and reference all of this information. This is kind of blown up to show you what's all included on this square. So we have the atomic number and the atomic mass. Then we have the name, the chemical group, and the symbol. So that's what you'd see for each one of the elements here. And when you're looking at the periodic table, you notice that they are listed in order of increasing atomic number. So hydrogen's 1, helium's 2, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, and so forth. So when we start at the top and we just go down from left to right, just like we're reading a book. So hopefully you've had an opportunity to pause the video, get a periodic table of elements next to you, and now we're going to start doing our first calculations. So here we can see Na, and on the periodic table, if you can find it, Na is sodium. It lists two numbers here, so it has the atomic number, and I said earlier that the atomic number is the number of protons. So that's 11 protons. Now there's no charge on this element. Otherwise you would see like +1, -1, blah, 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 blah. There's no charge listed here. So because there's no charge, this is a neutral atom. So the number of protons, which are the positively charged items, has to equal the number of electrons, which are the negatively charged items. So since we have 11 protons, we also have 11 electrons. Now this number 23 up here is our mass number. And this mass number is equal to the number of protons plus the number of neutrons. Okay, so our mass number is 23. So that's going to be equal to the number of protons, which is 11, plus the number of neutrons, which we don't know the number of neutrons, so I'm just going to put the variable x. Now we learned how to solve for x in the previous lecture, so we should be able to isolate the x. So we just subtract 11 from both sides, -11, -11. 23 minus 11 gives us 12. So we have 12 neutrons. So let's go ahead and actually draw this one out. So with protons, I'm going to try to go to this slide here and see if I can get some different colors when I start drawing. Okay, so I'm going to draw protons in red still. So we have 11 protons, and they're going to be in the center of the nucleus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then we have 12 neutrons. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now we have 11 electrons. So as I mentioned when we were going through the definitions, electrons are found in orbits that circle around the nucleus. So if what I just drew here is the nucleus, we would have orbits that surround the nucleus. The first orbit can only hold 2 electrons. And electrons I sometimes abbreviate E with a minus, and that's circled. So in this first orbit, we've got 2 electrons. Now, something you should know about charged particles is that opposite charges attract, like charges repel. So since these are both negatively charged, they don't want to be next to each other necessarily, so they want to be on opposite sides. So we've drawn 2 out of the 12 electrons, so we need to draw another orbit. Now, every subsequent orbit can hold a maximum of 8 electrons. So we're going to start distributing. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now we've drawn 10 electrons total, 2 in the first ring, 8 in the second ring. But we have 11 electrons, so we have to draw 1 more ring. And then we have a singular electron out here. So I'm going to pause the video now, or I'd like you to pause the video now, and I would like you to try to do the same thing we just did for phosphorus and oxygen. So for phosphorus, you're going to calculate protons, neutrons, electrons, and then draw it. Oxygen, you're going to calculate protons, neutrons, electrons, and then draw it out. Okay, hopefully you had a chance to do that. So protons, so our atomic number is our number of protons, and since it's uncharged, the number of protons is also the number of electrons. Now with the mass number, that's the number of protons plus neutrons. So in order to solve for the mass number, we would take 31 minus 15, which is 16. So we got 16 neutrons. So I'm going to change my pen color here, and we're going to go back to drawing the protons. So we got 1, sorry, it's not drawing, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Then we're going to draw neutrons, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And then we're going to draw the orbitals. On the first ring, we can only hold 2, so we're going to put 1, 2. On the next ring, we can hold 8, 1, 2, 3, 4, 5, 6, 7, 8. So now we've got 10 drawn, so we got to draw 5 more. So we got 1, 2, 3, 4, 5. So that's what that would look like. For oxygen, we have 8 protons because that's the atomic number. Since it's not charged, we also have 8 electrons. And then our mass number is protons plus neutrons, so if we subtract 8 from 16, we get 8. So we're going to draw this one real quick. Go 1, 2, 3, 4, 5, 6, 7, 8 protons. Then we're going to draw our neutrons, 1, 2, 3, 4, 6, 7, 8 neutrons. And now we're going to draw our rings. This first ring is going to hold 2, 1, 2. The next ring is going to hold 8. But we only need 6 on this ring because we have 8 electrons total. So 1, 2, 3, 4, 5, 6. So at this point, you might be wondering, why are we drawing out atoms and dealing with chemistry in QA Lab Math? In a math course that talks about quality assurance, why are we talking about atoms? You need to understand the basic structure of an atom to know how molecules are formed, and in order to understand how solutions are made and what molarity is. So this is kind of giving you the foundational knowledge so we can build upon that knowledge, and eventually you'll be able to do these solution calculations. Chemistry is also such an important part of the laboratory. It's important that you be able to recognize elements based on their symbol. So this is the list that I would like you to memorize for this class, but also for this program. Every student should leave this class knowing that H is hydrogen, Na is sodium, K is potassium, Mg is magnesium, Ca is calcium, Fe is iron, Zn zinc, Cu copper, Pb lead, C carbon and nitrogen, P phosphorus, O oxygen, S sulfur, I iodine, F fluorine, Cl chlorine, and Br bromine. So I went through those really quickly, but you have a periodic table of elements that you can then go back and review. You should be able to list the symbol if given the name, and list the name if given the symbol. So now we're going to go into a little bit more of how elements are laid out on the periodic table and how they're divided based on what type of substance they are in their elemental form. So most of the elements from the periodic table are metals, and metals have unique properties that result in them being charged or being able to conduct electricity. Now, you may not care about whether something's a metal or not at this point in your career, but we're going to talk a little bit about electrolytes and what makes an electrolyte an electrolyte. So we'll get to that very soon. So all of this will come back to what you'll need to know for the program. So metals are listed in that tan color, so you can see those are all drawn out here. Then we have metalloids, and metalloids are a combination of some characteristics of metals and some characteristics of nonmetals. And then we have the nonmetals, and a lot of our nonmetals are going to be gases in their natural form, but some are also solid. Our nonmetals are not going to conduct electricity, typically. Atoms can either lose or gain electrons to form ions. So ions are atoms that are charged. So in chemical reactions, atoms lose or gain electrons to form charged particles called ions. Positive ions are called cations. Negative ions are called anions. When we deal with running like gel electrophoresis in molecular diagnostics, you need to know what a cathode and anode are and what types of ions they attract. So it's really good to get this knowledge up front so that as you go through your program, you know the difference between a cation and anion. The way I tell these two apart is I am an animal lover. I have a ton of animals at home. Cats, cation, cats make me happy, cats are positive. So we have positively charged cations, negatively charged anions. Anions, if you think of anarchy, antagonist, an, you put something in front of a word, it's usually like a negative thing. So negative ions are called anions, positive ions are called cations. The charge of an ion is shown in the upper right corner, so here you can see an example of how that charge would look. In reactions, lithium atoms lose one electron to form lithium ions. Let me just slide this text out of the way because it looks like when the slides were converted over, they kind of went in the wrong spot. So let's make it so that you can read it. Here we go. That looks better. All right, in reactions, lithium ions lose one electron to form lithium ions. So here you can see lithium as an element, and if it loses an electron, that's what it would look like. So the charge of an ion depends on how many electrons were gained or lost and is given by the formula listed below, where P plus stands for protons and E minus stands for electrons. These can actually be calculated. One more time, we have to shift this around a little bit, just like how it transported in. There we go. All right, in reactions, fluorine atoms gain 1 electron to form fluoride ions. The charge of an ion depends on how many electrons were gained or lost, and the same formula applies. So why would sodium, for example, lose an electron, while chlorine, for example, gain an electron? Well, we're going to draw out, actually, let's just go back to our drawings, and I'll explain why based on what we've already drawn out. So if you recall, this is a drawing of the atom of sodium. So we have the nucleus, and then we have the rings of electrons. In order for atoms to be happy, they want to have a full outer ring. So the outer ring in sodium has 1 electron. This 1 electron that's left over is called a valence electron. Valence electrons are the ones that participate in forming bonds with other atoms. So if I have 1 valence electron, would it be easier to give up 1 electron or to gain 7 electrons in order to have a full outer shell? Well, it's easier for sodium to lose 1 electron, give that electron up, than it would be for it to gain 7 electrons to have a full outer shell. So sodium is actually going to be losing an electron when it forms bonds with other atoms. If a substance loses an electron, now electrons have a negative charge. If you give up negativity, you become more positive. So sodium losing 1 electron means that sodium is losing 1 negativity point, and when it loses that, it becomes positive by 1. So sodium's charge, you can see, is +1, which they annotate just by the plus sign. Now let's go back up here and look at oxygen, for example. So we drew out oxygen here, and oxygen has its nucleus and it has its orbits that are circulating. Now oxygen has 6 valence electrons in its outer shell. With oxygen having 6 valence electrons, it's already almost all the way to the 8 that it needs to be happy. So would oxygen give up its 6 electrons that it has, or would it gain 2 electrons to get to the full outer shell? Well, in this instance, it would just gain 2 because it's easier to gain 2 than it would be to lose 6. So if you gain 2 electrons to become an ion or to help form bonds, you're becoming more negative by 2. So this is where you would have an electron charge of, or ion charge of -2. And you can see oxygen on this periodic table here, we have O2-, because in its ionic form, it's gaining 2 electrons. So, as a review, elements are made up of atoms. Atoms are the building blocks of all matter. Atoms have protons, which have a positive charge and are in the nucleus, or the center. Neutrons, which are neutral and also in the nucleus. And electrons, which float around the electron cloud surrounding the atom. An atom is just the building block. An element consists of lots of the same type of atom, and molecules consist of different atoms bonded together. The atomic number is how atoms or elements are arranged on the periodic table of elements. The atomic number is the number of protons in the nucleus. The mass number is the number of protons plus neutrons, while the atomic mass takes into consideration the very small mass of electrons. So mass number is usually a whole number, atomic mass is usually has a decimal. This is a shorthand expression for an element that shows the symbol. This one happens to have a charge, and then a mass number and atomic mass. You learned how to draw out atoms based on arranging them in the shells. These drawings will not be on an assignment. They will not come up on the test. This is just so you can visualize in your mind how and why molecules are formed in the way that they are. You need to know the element's symbol and name. So you need to be able to know name to symbol, symbol to name. And then you need to know what an ion, cation, and anion is. So ions form charges, positives are called cations, negatives are called anions. When looking at the ions that are laid out here, most of our cations are going to be on the metal side, most of the anions are going to be on the non-metal side.